Hello, and we are going to be doing Lab 5, Igneous Rock Identification. So you are looking at one of my countertops. I took it out of my old house that I renovated and brought it with me to where I live now. And one of the cool things about this, it's sold as a granite countertop. It's technically not granite, it's another form of igneous rock. So when you go to a granite place, lots of them will say that everything they have is granite. Well, that's just a business model. That does not mean that's exactly what the rock is. And our job today is to change your perspective on what igneous rocks look like, how they're formed, and the characteristics that make them either felsic, intermediate, mafic, ultramafic, and there are two types of textures, which are phaneritic and aphanitic. If you have not read the book for this section / chapter, you absolutely must. If you've not watched the lecture video, ditto, you must. You will be so lost. So I want to give you a heads up right now. Those two things are essential to do this lab. So let's get started, and I want you to begin by always checking the bright space announcement in, meaning the rundown, for the lab folder, because there's two additions to the igneous rocks for this lab, and they are both of the ultramafic rocks. So make sure that you add them as noted there. If for some reason you don't find them, you can look at the information in your book, and there is a chart that has the names of those rocks as well as they're described within the text. So let's get busy, and I need to revisit a few key terms from the lecture, and that's the Bowen's reaction series. And the reason that you needed to do minerals lab before you did this one is because minerals make up rocks. Rocks don't make up minerals. And so, as I said in my lecture, these minerals and the accumulation of them determine what type of chemistry that you're going to have in igneous rocks. For example, this chart's kind of backwards from the way others are, but I like it because it starts with the high temperature where you can relate to it at top and the lower temperature down here. And you can see the ultramafic has a lot of the greenish minerals, and then the mafic has some green and black and dark grays, and then you get to the intermediates. And as you're seeing that, as you're going down this way in composition, which is the chemistry, you'll see the temperature is decreasing. So if you remember a couple of really important minerals, olivine, remember that one, the green one? Well, that forms in ultramafic, but also down here in mafic, more commonly right around this boundary marker right here. And let's take a look at potassium feldspar. That was the pink one. You see how that's why this one's pink. And then you get these intermediate ones where you get the biotite and mica and so forth. And this muscovite mica down here, that's actually what you had in your lab as well. So I just wanted to point that out because when we're talking about chemistry of igneous rocks, we're talking about its composition, the minerals that make it up in dominance. So as we get started, one of the first things you need to remember is aphanitic versus phaneritic. And aphanitic refers to igneous rocks that crystallize or cool off at or near the surface, which would be things like lava. So the aphanitic rocks correlate to their chemistry. Here's your felsic, your intermediate, your mafic, and your ultramafic. That's the same as composition. So the felsic aphanitic rock or lava would be rhyolite. The intermediate, here's your intermediate, would be andesite. Your mafic, here's the lava, basalt, ultramafic, comatite. So this top line here represents all the aphanitic igneous rocks, meaning they're extrusive. And then you get your matching rocks, which are called equivalents, in each category. So there's a matching one for rhyolite that's intrusive / plutonic for felsic, and that would be down here. Granite, diorite, gabbro, prototype. for each of these as you start to go felsic, intermediate, mafic, and ultramafic. So phaneritic simply means there's interlocking crystals. Make sure you are using this tool because there is a felsic, intermediate, mafic, and ultramafic group of margarita mixes. The minerals in here in the middle section of the chart dictate if it's felsic, intermediate, mafic, or ultramafic. And remember, there's a extrusive and an intrusive for each type or each group. So the phaneritic or intrusive / plutonic rocks that are made by igneous, the felsic one is granite, the intermediate is diorite, the mafic is gabbro, and then the ultramafic is peridotite. When you get to the aphanitic, the felsic is rhyolite, and there's like lots of different types of rhyolite, just like there are lots of different types of granite. On the intermediate, the lava is andesite. In mafic, it would be basalt. Like rhyolite, there are about a dozen different types of basalt, so you're going to be looking at least 5 or 6 in this lab. And then the ultramafic, we don't really have very many of these left, and most, quite frankly, have been metamorphosed, but they're called comatites. And they are the lavas of ultramafic. We don't typically make them anymore. They are from geologic past, the Precambrian eon. So again, you have matching margarita mixes. The difference between the two is where did they cool off and where did those minerals crystallize. So the phaneritic texture would produce the interlocking crystals such as granite in the felsic category, but you get that same magma that comes to the surface and spills out as lava, then you're going to have a rhyolite or a form thereof, like volcanic breccia, volcanic tuff, pumice, obsidian, things of that nature. All right, so now it's time to get out your Lab 5 bag, Igneous Rock. And I want you to pull out your sample bags, line them up 1 through 10, but do not get out all of the samples yet. Before you do any of that, let me give you a heads up, super important. Igneous rocks can be very sharp by the sheer nature of how crystals grow or just the type of rock that it is. For example, volcanic glass, which has a very special name called obsidian, has razor sharp edges. In some cases, it's used as surgical tools. Be very careful as you're handling these. Some of our extrusive igneous rocks, like scoria and pumice, actually could potentially have some volcanic glass in them. And the vesicular nature makes them very rough, so they can be really tough on your skin and even cut you. Some of the phaneritic igneous rocks can have very interesting arrangements of their crystals with the interlocking crystal matrix. So again, they can be kind of rough on your hands. Just be careful. I'm also going to ask that you do something for me as you get your lab workspace all set up. Go get a glass of water, but fill it about a little over half full. And it needs to be one that's a regular size glass, not a tiny little, like shot glass or something. It needs to be big enough that samples have room to fall. And that's important because ones that have a lot of holes or that aren't very heavy, you can kind of determine if you've got like a form of rhyolite called pumice simply by seeing if it floats. And that's one of the cool things about this lab. So just because there's a lot of vesicles and it's technically a subtexture called vesicular does not mean it's automatically going to float. So I'm not going to tell you that scoria, which is a mafic type of basalt that is very similar to pumice, which is felsic, can't float, but it's highly unusual because it's pretty dense with a lot of lead, and well, specifically iron. And the iron content in basalt, usually you would get a sample like that, it would just go plunk to the bottom. But if you had enough vesicles, it might float. But if you compared it to your pumice, I'm pretty sure that even if it did, it would sink a bit. So I just want you to have that handy and always prep out your workspace like this so you have the equipment you need to test, just like we did with minerals. Okay. So just like we did in minerals, you're going to be using the geology.com. Before you start, you should go look at each of these rocks. Now, the pictures that are in geology.com may be similar. They may not be completely similar to what I have. They're still the same thing. The key is the description. But I've shown you enough pictures in lecture that you should know the difference between like the various types of basalt. So like you get into geology.com, it's not going to have hoi hoi or a, which is spelled a, but it's a in Hawaiian. But it would have something like vesicular basalt or something like a flood basalt. Well, it's okay if it's not listed there. It's just a website. I'm giving you the more specific information because they're things that you might need. So go back to the lecture and look at the different types of basalt, like Pohoi Hoi has a smooth and ropey appearance. A'a is very rough and sharp. And then you would have something like a flood basalt, which is a very dense type of lava. And that's mafic. So that would help you delineate what you've got. All right, so I need you to pull out that sample 1. And when you do, I want you to get your testing equipment out. So just like we did with minerals, start with your magnet. Did it kind of stick? Did it not? Mine did not. Then I need you to do the old test. This one tastes like dirt, just so you know. And then I want you to streak it. And keep in mind that rocks are made up of minerals, so it's possible you could have more than one outcome for these tests, but it gives you a general idea. That's the whole point of learning how to use your testing tools. Then you're going to test for hardness, and you're going to maybe use your acid if you have it to test and see if it reacts. This one will not react, and interestingly enough, there's quite a bit of quartz in it, so it could be hard, but yet how it's made, the sample, it should probably have scratched pretty well. Put it in that water. Did it sink or not? Mine surely didn't float, so you can kind of do it. So the first thing I want you to do now that you've tested it is let's do a visual assessment of color. Is it white, tan, pink, very, very light shades of gray? So white, tan, pink, very, very light shades of gray. And the answer is yes. That puts it in the felsic category. So if it were, we'll come back to intermediate in a second, but if it was a very dark shade of gray, super dark, black with a little green maybe, that would be basalt. Dark green and black together dominantly would be ultramafic, and then 50 shades of gray would be your intermediate. So once you've determined if it's a felsic, intermediate, mafic, or ultramafic rock, then you look at, does it have interlocking crystals? If the answer is yes, then it's phaneritic, and you look at that line on the chart that has the phaneritic arrow pointing to things like granite, diorite, gabbro, or peridotite. One way you might need to do that is with a hand lens or a some type of a magnifying glass. So I'm going to do that with this one. Now mine has a little light on it, which is super useful. And I'm just taking a sample to get really close to it to see that there's, well, it didn't in the dark have a lot of crystal faces. When I actually get it with the hand lens or magnifying glass on it, it did. So it also is fairly heavy for its size, or heavier than some of the ones like the one you should have for our sample one. This one isn't very, very heavy or dense for its size. I don't see anything that would suggest that number one is phaneritic. Then you have to ask yourself, once you determine it's aphanitic, does it have any subpersonalities, the subtextures? Is it vesicular? I don't see any cavities. No. Is it glassy? I don't see that. Is it pyroclastic? Could be, but I don't really see evidence of that. Porphyritic means it has some crystals, but they're not interlocking. I don't really see that either. So this is just a plain Jane piece of whatever it is. Now you determined it kind of had a pinky, whitish tan color, so that puts it in the felsic category. Go back to that chart. Which is the felsic aphanitic igneous rock? And there you have it. Now remember, I told you there were multiple types of this, so you need to go back to your book and look at the differences between the different types of this specific one. Okay, here's your colors down here to help you remember on each and every one. So just to recap, we're going to be looking to determine if it has what color it is, to put it in this category, and we're going to be looking if it has interlocking crystals or not. If it does, we know it's sphagneritic. If it doesn't, then we know it's aphanitic. If we find out it's aphanitic, then we look and see if it has textures to it, because that can help us determine what we've got. All right, put number 1 up and get, oh, by the way, did you put it in water? I did. It didn't go anywhere. It just, except to the bottom, like it didn't float. All right, number 2. So I want you to test this just like you did number 1. You're going to get out all your testing equipment, and remember, you'll do the magnet. It might actually have some attraction because there's quite a bit of iron in this. May or may not. Depends. And then you're going to do a streak. Then you're going to do the hardness test, do the taste test. Tastes like a piece of lava to me. And then we are going to test it with acid. Nothing happened in my case. Then I want you to put it in water. My sample went plunk, even though there's all these little gas cavities called vesicles in there. In other words, it didn't float. All right, so let's get to A and B. Does it have interlocking crystals? So I'm looking at my sample. Your sample may be black. It could be a reddish color. Same thing, okay? It's just the iron in it that will determine how long it's been exposed in nature as to which way it is. So it does not have interlocking crystals. It has to be aphanitic, and here's why. It has vesicular subtexture. Look at yours, and you should see little gas cavities everywhere called vesicles, bubbles or holes. Those don't form as sphagneritic textures, so this is definitely an aphanitic lava. Now, what color is it? Well, is it black or red, which is pretty much all the samples that were provided to you in your kit? The answer is yes. So that's the only place it's going to fit is mafic. Which of the rocks that are aphanitic is mafic? Okay. Now, since it was dense enough to sink, it's not, it can't be pumice because pumice is going to be a felsic. So it's like that. Which one of the rocks that you learned about that was mafic is a form of basalt, because you now know that basalt is the mafic igneous aphanitic rock. Which one is very vesicular but fairly lightweight? And that's what you've got here. All right, moving on to sample 3. All right, this one, let's start by examining it with all of your testing equipment. Again, you're going to do the, get out the streak and hardness test, do a taste test, do a magnet test, acid test, kind of figure out what it looks like. And then I want you to determine, does it have interlocking crystals? Mine doesn't. All right, so we know that it can't be phaneritic. It has to be aphanitic. From there, I want you to see, does it have any of one of the 4 or more? I mean, it can have 1, 2, 3, or all 4 different types of subtexture. Or I might add, there's one more choice. None. This one doesn't appear to have any of those. Okay, so I'm going to say it doesn't have any subtexture. Then I want to determine what color it is. So we know it's aphanitic. We know it doesn't have really any subtexture. All right, is it felsic? Is it pink, white, tan, very, very light shades of gray? Well, it's gray, but I don't think it's a very, 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 very light shade of gray. Well, it's gray with some white and some black, maybe, but it's gray, right? And remember, intermediate's 50 shades of gray. It's not black and red or brown with some green, and it's not black and green. So the only category it fits is intermediate. So we know it's aphanitic and we know it's intermediate. What is the name of that igneous rock? And that's what you've got. By the way, did you put it in to see if it floated? It's tiny enough, it might not sink very well, but it should not float. Technically, it shouldn't. All right, be careful with the next sample. All right, when you get it out, you could have a variety of different colors. This does not just come in a black color. And just for the sake of categorizing by color, we're going to do color with this one and say black. And you could go, okay, yeah, I think it's mafic. Technically, it's more like 100% silica, so it's really felsic, but we're going to do a color to help you get used to that. So my sample's black, and there are some brownish red ones that are in the middle of your sample boxes, so you possibly could have that. One thing right away you should notice is that really get it in the light. So again, I'm going to get my hand lens on. Actually, hand lens on. Get this there, and there are no interlocking crystals whatsoever. None. Instead, it's one giant thing, okay? And this is just a piece of that giant thing. It used to be much, much larger. So here's what happened. This super cooled in the atmosphere as lava and stuff came out of the volcano and an eruption occurred, forming volcanic glass. So there are no crystals there. It is essentially just super cooled silica. So that was an instantaneous thing. That means it has to be aphanitic. Okay, has to be. So we've already established that it has a subtexture of glassy. I mean, you can look at it and see that. Now, which of these colors best fits? And I think we decided it would be mafic. So what's the name of the rock that is a glassy, called volcanic glass, has a very specific name? That is what you've got here. All right, let's move to sample 5. This is one that getting a hand lens on it is super important. And as I look at it, I can definitely see interlocking crystals. I don't really even need my hand lens to see that. I can look at it and just see it in the light. But I want you to get it in the light. Like I want you, if you have a bright light, and I'm just gonna grab one of my bright lights that I use here, and I'm gonna stick it in there and I'm gonna look at it, and I can totally see interlocking crystals. Once I get it in the light, I can see it. So that's what you're needing to do in order to look for interlocking crystals. Really get it in a good light, and this one certainly has it. What's the first thing that we know about interlocking crystals? Is it aphanitic or is it phaneritic? Yep, you guessed it, it's phaneritic. All right, so the next thing you do is look at the color scheme. So I realize there's some black in there. That's okay. What's the dominant matrix or the background? Mine is a reddish pink, and it's pink, pink, pink. Remember potassium feldspar that you learned about in minerals? This thing's loaded with it. So which one has the pink? Felsic, you got it. So now that you know that, it's felsic and it's phaneritic. What's the phaneritic felsic rock? The cool thing about phaneritic rocks, man, is there's no guessing. It is what it is. It's either granite, diorite, gabbro, or peridotite. So this one's got the pink, so it must be whatever the pink, meaning the felsic phaneritic igneous rock is. When you get out sample 6, the first thing I want you to do is get a hand lens on it or a bright light and turn it in all different directions. And as you do, you're going to notice there's lots of black crystal faces. That tells you it's interlocking. All right, so we know it's phaneritic because it has interlocking crystals. So it makes it pretty easy. Then you look at the color. It's black. Don't see green in it. It's just solid black. So that's going to put it in the mafic category. Look at your chart. Which one's the mafic phaneritic? Boom! You got your answer. All right. Let's get out sample 7. Same thing. Get it under a hand lens or a bright light, turn it in all directions, and you will see multiple crystal faces. In other words, the crystals aren't interlocking. What does that tell you? Right away, it tells you that it's phaneritic. Now, what's its color scheme? Sure, there's some black in it, but is that the dominant color of the matrix of the background? No. you kind of got a whitish tan, like a cream color. So which one does that fall in? Felsic, intermediate, mafic, or ultramafic? And you guessed it, has to be felsic. So what's the phaneritic felsic igneous rock? There's your answer. And you're like, well, I've already had that. Okay, you're going to have it some more probably, because it's a very common thing. Igneous rocks are categorized almost like a generic brand of stuff. And so there's lots of different kinds of it. These are just the big dog names that go with them, right? I mean, they're just, you get a bunch of granites, you get a bunch of rhyolites, you get some andesites and a diorite, you get for basalts, lots of basalts, and then you just get gabbro and so forth. So it's pretty straightforward. All right, so let's get out number 8. And as you get it out, darn, how lightweight is that thing? Like air light, right? I mean, I'm not joking there. It feels like air. It's because it was made of a lot of air. It has lots of gas cavities in it. And essentially, this is just some ash and material that's solidified together in flight. So there's a lot of vesicles when you get a hand lens on it. You can see that. I'm looking at it. Man, I can see it right away. So one of the cool things about this is put it in some water and see what happens. And that's kind of the really good giveaway that you have this particular igneous rock that's felsic, because we know it's the right color to be felsic. So there's lots of different rocks in the rhyolite category. There's just a rhyolite lava. There is volcanic tuff and volcanic breccia, which I've kind of lumped together in this lab. Those are welded materials that get done in flight. They're pretty dense. They will not float. And then you get pumice. Pumice will float. So that should tell you what you have for sample 8. All right, sample 9. Wow, this is pretty darn dense. Do you agree with me on that? So take a look at it. I realize it's kind of rounded. You're like, well, how did that happen? Happened in a riverbed. You'll learn more about that later on in the semester. So I can look at it under my hand lens. There are 0 interlocking crystals. This is just a rock that's been tumbled down a riverbed. So let's look at color. So we know it's not phaneritic, it's aphanitic. Do you see any vesicles? Nope. Do you see any glassiness? Just because it's smooth, there's no true glassy texture like you saw in obsidian. Is it pyroclastic? Kind of like the pumice? Nope. Porphyritic, meaning does it have crystals of other things that you can visibly see that aren't interlocking? Nope. So it's none of the above. It's just lava. Now, what color is it? Black. So if it's black, there's not a green, black and green. So that means it's in the mafic category. So what's the lava that's in the mafic category? And it's kind of interesting. Some of this rock may actually attract a magnet. So check on that to see. It really depends on how it cooled and the amount of iron that's in the magmatic material that forms it. All right, let's get to sample 10. All right, this one I'm going to have you get a little light on it. As I get close to it, I do not find interlocking crystals, but what I can clearly see is there's a hodgepodge of stuff that's been welded together. That's a pretty good clue. All right, so it can't be aphanitic. It can't be phaneritic. It has to be aphanitic. So the welded part means it's pyroclastic. Very much so. Now also keep in mind that a rock like this might have more than one subtexture. Maybe it has a couple of shards of glass in it. So it could also have some glassy stuff. It could have some vesicles. I'm not saying this one does, but it could. So it could also be vesicular, and it might have some random crystals in it that are throughout the rock, but they're not interconnected. So if that's the case, then it could be porphyritic. My point is that you can have more than one subtexture. So we know that this one is pyroclastic for sure. Okay, let's go to the colors. So this one's a very, 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 very light shade of gray. So you might go, but it's gray, and there's 50 shades of gray, so it's intermediate. No, This one's so light you could almost say it's on the borderline of being white or being a cream tan kind of color. So it's going to be felsic. So which is the rock that is felsic, that has welded material from pyroclastic eruptions? And you're going to know exactly what you've got. All right, get your stuff packed up. Take a minute to take a break. And when we come back, we're going to do samples 11 through 25, just like we did with minerals. See you back in a few. Alrighty, welcome back. So it's time to do the remaining samples, and these are pictures. So I'm going to help you do them, but now you kind of got to apply that. Okay, yep, I'm going to look for interlocking crystals, and then once I determine if it's phaneritic or aphanitic, then I'm going to look at the color. And I'm going to help that drive my decision making in order to determine if it's felsic, intermediate, mafic, or ultramafic. And then that aphanitic versus phaneritic tells us which specific rock group it falls in. Okay, I'll help you along the way. Alrighty, so let me give you perspective on how big this thing is. This thing's about the size of a computer, a regular size laptop. Okay, so it's not a small thing. So you had a sample similar to it earlier, okay, but this one's pretty dense. So I guarantee you if I had a bucket full of water, this thing would not float, even though it has giant vesicles in it. So the vesicles are the dead giveaway. It's vesicular, so that means it can't be having interlocking crystals. That's first thing, straight up, okay? Now, it used to be black. Why is it kind of a brownish red? Because that's what iron does as it's out in nature. So this is how this particular type of igneous rock weathers, and why places like Hawaii on the side that's no longer very active has such rich coffee, because this stuff weathers down and makes very rich soils. All right, so remember that we know that it's not phaneritic, doesn't have interlocking crystals. We know it's aphanitic, and that it is vesicular, okay? And we know it's mafic because it's brownish red. It used to be black. What rock is that? Now, there are multiple names for this type of rock. I mean, the generic name is, you can look it up on the chart. Well, I'm going to help you with this one so we get it right from this forward. So there's Pohoihoi basalt, there's Aa basalt, there's scoria, and then there is just plain Jane, what we call flood basalt, which is just lava, okay? Aa is very sharp, usually very vesicular. Then you have Pohoihoi, which is smooth and ropey. It also can be vesicular. Then you've got scoria, which is very, very, very lightweight. Okay, so it looks very much like this, but it's very lightweight. Then you got a dense lava that doesn't have the vesicular texture. Matter of fact, it just typically doesn't have any of the characteristics, maybe a little porphyritic in it. So in this particular case, you are looking at the Aa. It's rough, it's sharp. So I want to give you help there, because the rest of the ones that fall in this category, you've got to do them on yourself, okay? All right, number 12, interlocking crystals or not? Well, the hole should give you the indication. If there are any vesicles, the answer is no. So it's aphanitic. This is a white color. Which text or which chemistry does that fall under? Felsic, intermediate, mafic, or ultramafic? Once you determine that, there's only one of these rocks in that category for that aphanitic rock that floats. That's what you've got here. Let's move on to sample 13. All right, what do you notice about the color, first of all? Let's start there. Kind of has pink and white, doesn't it? Pink is important. Remember, there's only one chemistry group that has pink, and you guessed it. It is the felsic. All right, so I've seen vesicles. No way this can have interlocking crystals. Well, I do see a handful of random crystals in here, like this one right here, here. that means it's porphyritic, but they're not interlocking, so it can't be phaneritic. So pink puts it in the felsic category. What is the rock that this would entail? So just like the one we had before, this one can have a variety of different names. So I'm going to help you out with this one. We know it's in the rhyolite category. So is it just a plain Jane lava flow of rhyolite? You wouldn't see all these sub-characteristics. The answer is no. So then there is pumice. This one doesn't float. Okay, so it can't be that. And then you have volcanic breccia and volcanic tuff, two different things, but we're going to kind of lump them together in here. And that's where you have stuff that's welded together. So you get to make a decision based on all that information and go from there. Okay. Alrighty, sample 14. This does not have interlocking crystals. If they were interlocking, it looked like this. While you do have these black kind of hornblende minerals here, they are not interlocking. So this is a type of lava. So look at the gray, and you see that the background has no interlocking crystals, just some random things kind of floating around in it. You can also see it from the side here. That's important because that tells a story. Then you have already established, once you looked at that, it is non-interlocking. That means it's aphanitic. So the next thing is color. So this is a gray color. It's one of the true 50 shades of gray. It's getting up there towards a light gray, but it's not quite there. And because of that, that puts it in the intermediate category. What's the name of the intermediate aphanitic igneous rock? That's what you got here. Moving into sample 15. All right. See if you can do this one. First question, does it have interlocking crystals? I've given you two pictures, a regular shot and a close-up shot. Okay, have you answered that question? The next one would be, what color is it? So it's just pretty darn right black. Okay, so that helps you. So if the key is, does it have interlocking crystals or not? And I'm going to have you make that determination based on this because it's pretty obvious in the picture if it does or if it does not, okay? And once you figure that out, there's only one thing it can be. And from there, you're good to go. All right, moving on to sample 16. Well, you're like, oh, I know what that is. Good. First thing, does it have interlocking crystals? You bet, okay? You can see some potassium feldspar, some biotite, and then you see some quartz in here and some mica. All right, so these are fairly large crystals. So that's kind of important because you learned about in lecture crystals of a certain size that are large that you can see without a hand lens. Those are called pegmatites. And pegmatites are pretty cool because they generate some really important gemstones and sometimes some other stuff like some ores and things of that nature. So we know it's phaneritic. And the pink is a really important giveaway as to which chemistry it would be. But that pegmatite thing is worthy to make a highlight here, okay? So then you get to tell me what it is. All right, let's move on to 17. First thing, let's look at it. Does it have interlocking crystals? All the way through it. And if you can see it, there's a green crystals all the way through it as well, which gives it a fairly hefty, almost a lighter color shade than black because there's so much green in it. And then I see the black interlocking crystals as well. That's important, okay? So on this particular one, you are needing to focus on those black and green crystals because when you get a dominance of that, that puts you in a rare category of igneous rock. So we know it's phaneritic because it has interlocking crystals, and it is that unusual type of igneous rock that predominantly formed during the Precambrian eon, and because you got a lot of the olivine and darker minerals in there. So what rock is this? Let's move on to sample 18. Woo! You can see those green crystals, right? Now, first thing you look at, what do you notice? All right, I see the vesicles can't be interlocking because these green crystals do not interlock with each other. or other crystals. So the vesicles are dead giveaway that we've got an aphanitic igneous rock. Okay. And then we got a special type of subtexture besides vesicular. We also have these little crystals that were floating in the magmatic material or in it, maybe even at the bottom. And when they came up in the eruption, they cooled off in the lava. So that makes it also porphyritic. Important thing. It's a black rock. Yeah, it has sun green crystals, not a dominant. So it's sitting kind of on that boundary marker where it can make olivine, but not a bunch of it. So it's mafic, and it has olivine in it. So look at your choices and see what you think it is. Moving into sample 19. All right, you're like, whoa, wait a minute. This one's kind of unusual. Let's kind of pull this thing apart, and I'm going to work this through you. We're going to start with, is it aphanitic or phaneritic? Do you see the layering in this thing? So this is a little bit of just random crystals that have rusted. But do you see the lines going through it? It's kind of layered, which is an indication of lava, okay, right away. There might be a random crystal or two in here, but not much of one. So this has virtually no, if any, subtexture. Now, the big question is it felsic or intermediate? Because you can guess it's gray, but it's such a light shade of gray that it can't be intermediate. So it's really on that boundary marker. That's why I wanted to help you with this. If it was in the intermediate category, I would give you that guidance here. I wouldn't want to be tricky. So I'm giving you guidance that it's not intermediate. Okay, it's just got too much silica in it. So that should help you determine what you have. Let's move into sample 20. All right, first things first. Very rare, and quite frankly, most of this has been somewhat metamorphosed, and black with a lot of green. There are no interlocking crystals. So first of all, we know it's aphanitic because there's no interlocking crystals. There's hard to say, I mean, it does not display one of the characteristics of subtexture. The key thing is which of the matrix color do you have, and it's black and green. It's harder to see the green until you get really close up to one of these rocks, but it's in this category right here. So what's the name of the igneous rock that would fall in that group? It's extremely rare. All right, let's move into 21. All right, take a look at this guy, and let's kind of look at the background color. While you've got some black, you've got some white crystals. A dominance of it's very gray. There's a lot of orthoclase in it, specifically plagioclase feldspar, but they are definitely interlocking. And if you can't see that, like this white crystal smushed up against these dark gray ones and black ones and vice versa all the way through. So we know it's phaneritic. So we don't have to worry about any of this. That just means we're coming down here. So when you have a dominance of gray, that puts it in the 50 shades of gray. I want you to look at your chart. It's phaneritic, so go over and find the intermediate that is phaneritic. That's what you got. Easy, right? All right, it is. All right, moving into 22. Here we go. We're looking at this thing. This is about the size of a cantaloupe, so it's about this big, okay? So it's not this little bitty thing. If I put it in water, it would go plunk. First of all, you might notice there's vesicles all over the place. So what does that tell you? Is it aphanitic or phaneritic? It has to be aphanitic. There's no way it's going to be phaneritic. Plus, I don't see any interlocking crystals anywhere. And you wouldn't with this particular igneous rock. And I see some red, some tan, and red and brown and black. So black's the color right here. This is a volcanic bomb from Hawaii. So when you look at this thing, is it felsic, intermediate, mafic, or ultramafic? And remember, it's a pretty standard black color. It can't be lightweight enough that you could call it one form of this. That would be what you probably see in fire pits. This is different. This is pretty dense. It's fairly heavy. I mean, I had to carry it on the plane, and the people back then. This was before checkpoints were as bad as they are now, because it was before a very infamous date in 2001. They checked my bag, or they checked all my stuff, and were like, because it sent off a siren that there was iron, because it was pretty high in iron. And that's no surprise, because of where this came from in Hawaii. It produces this type of lava all the time. Moving to 23. Look at this thing. I bet you're like, I know what it is. Awesome. Go through the process. Does it have interlocking crystals or not? I see lots of black and white, and they are sandwiched, smashed together. All right, that's a start. So we know it's phaneritic. Well, let's go to the matrix color. It's predominantly a white color. Would that put you in the felsic, intermediate, mafic, or ultramafic category? You tell me which one it is, and you should be able to guess that by now. It's pretty easy, right? All right, my personal favorite of the bunch, 24. What do you notice right away? Smooth. Number 24. My personal favorite, because it's smooth and ropey. All right, that's a clue. Okay. Now, in the picture, it kind of has a dark gray. It's really a solid black color if you saw it. It's just you can't capture that without a perfect camera. And I took this with my phone, so it's not a perfect picture by any means. This is about the size of a screen of a normal laptop, certainly of a big iPad. And it is black. It's vesicular, so it can't be phaneritic. It's aphanitic. So when you get to that in a group of aphanitic rocks that's black, it's a very special type of this because it's smooth and ropey. That's the big giant clue. Okay, that means we're coming up to 25. We're almost done. All right, here's 25. You're like, whoa, what's up with this? Right, this is a fairly large sample, again, about the size of a screen of a normal laptop. And I do not see interlocking crystals, although I see some random crystals. Like this is a pretty big, what we call phenocryst right here. So it tells me it's not interlocking. That means it's aphanitic. So we got some porphyritic texture, maybe a little bit of vesicular, but that's about it. But the color's the key. This is the true shade of gray. Does that make it felsic, intermediate, mafic, or ultramafic? There's only one rock it can be. Identify what that is. So we're wrapping it up now, and here's my igneous clue. So you may go, I don't see igneous rocks there. Well, most of them aren't. Most of them are sedimentary, but there are some hiding around the pond at my house here. And the clue is kind of cool because there's something going on right here. The other of these things, get some water feature stuff going on back there. But here's what I want to leave you with. You got to use your lab form to take your lab assessment by the due date and time on Saturday. And you also are going to need to upload that lab form to the assignment tool, same one you've been using all semester. Make sure you take both attempts. Make the best grade possible. The next lab we do together will be sedimentary, so I'm looking forward to doing that with you, but you have one in between this one and that. Doing a great job. Stick with it. Bye.